Allow me today to take you through a very important topic in various curriculum across the world that we call uh, straight line. When you talk about straight line, there are a number of basic things that I want you to know about straight line. There is, first of all, when you talk about straight line, what we call the gradient of a straight line. Gradient of straight line. Gradient of straight line. This is a very, very important topic. But then how do you get the gradient of a straight line? Normally, we normally say that the gradient of a straight line is represented or is given by the formula is equal to change in y coordinate, change in y coordinate. You divide this by change in x coordinate. Change in x coordinate. I would like to simplify this by drawing, like let's say, if I have a y and the x axis is there, then I have this particular line like this. So this is what I'm looking for. I'm looking for the gradient of line. I can call this line xy. And this line xy, it is passing through the x-axis. This is the x-axis, the horizontal one. Then this one here is the y-axis. The y-axis. Maybe I can use other letters to call this line. I can name it as line PQ. So this line PQ, it is cutting through the x-axis at this particular point, and it's also cutting through the y-axis at this particular point. At every point where this line PQ cuts through the x-axis, it cuts through the x-axis at two coordinates. Let's say the x coordinate here is 3. On the x-axis, the y coordinate will always be 0. Then here, on the y-axis, the x coordinate will always be 0. So the coordinate here is 0. Then let's say preferably the y coordinate here is 6. So what is happening? I have two pairs of coordinates where line PQ is cutting through. So for instance, if I am asked, find the gradient of line PQ. Find the gradient of line PQ. Then I will say, I know that the gradient of a line that is also represented as M is equal to, I already said, change in y over change in x. So we normally talk of what? Change in y coordinate over change in x coordinate. For this particular case, I have two pairs of coordinates here. The first one is x, y coordinate. Now what happens? I'll call this as my x1, y1. This as my x2, y2. So that now here I'm saying that the gradient of this line PQ is given by y2 minus y1 out of x2 minus x1. I hope you're following and you're moving together. Therefore, we will then go ahead and find the gradient of this line. My y2 is 6. Therefore, I say 6, take away y1, which is 0. Everything out of x2, which is 0, take away my x1, which is 3. When I subtract, I'll get 6 take away 0 is 6 out of 0. Take away 3 is negative 3. So what is my gradient of that particular line? My gradient of that particular line is 3 here 1, 3 here is 2. Because 3 is negative, the gradient is negative 2. And you can see the slope of that line. Because the line is descending, so the slope of the line, the gradient is what? The gradient is a negative. So that is how you find the gradient of a straight line given two pairs of coordinates. Now, after I have taught you about this, these lines normally, they correlate. For example, you will find two straight lines that are parallel. What is the relationship between their gradient? Or in another scenario, you will find two lines that are perpendicular to each other. What is the scenario or what is the relationship between their gradients? I want to teach you about that. Apart from that, also, I want to talk about how to find the equation of a straight line given two pairs of coordinates. Now, before I talk about parallel lines and perpendicular lines, allow me to first of all teach you about a very important concept that talks about finding the equation of a straight line. Now, so I hope this is clear and you are able to follow through. So allow me to clean the board as I talk about the other bit that I've just mentioned now. So I hope that is clear and you can be able to follow through. Now, I will use still the coordinates of the line PQ that I've just talked about. So this one is equation of straight lines. Equation of straight lines. Equation of straight lines. So I want you to follow through, you see. Equation of straight line. Now, looking at this, then I'm saying that I will talk about this by giving you examples. So the first example will look like this. First example of equation. Find the equation of line PQ given that the coordinates at P are, let's say I'm talking about 0 and 6, and Q we are talking about what, 3, 0. So those are the coordinates. So if you are given this kind of an equation, it says that find the gradient, the equation of a straight line. Let's say probably they have not specified in which form your equation is supposed to be. So they have just said find the equation of a straight line. Find the equation of the line PQ given that the coordinates at P are this and Q are this. So the first thing that you do here, you must find the gradient. And I've already told you gradient is equals to change in y out of change in x. Because I have P and Q, I'll simply say this is my x1, this is my y1. Therefore, this becomes my x2, this becomes my y2. I go ahead and tell you gradient of that line. First of all, we need to get the gradient. That's where we start from. So the gradient is equal to y2 minus y1 out of x2 minus x1. I go ahead and find the gradient, which will be 6 take away 0 out of 0 take away 3, because x2 is 0, take away 3. So what is my gradient? 6 out of negative 3. Therefore, our gradient is equal to here 1, here 2. Therefore, our gradient is negative 2. With the gradient now, we go ahead and find the equation. So we will say let line PQ pass through. Let line PQ pass through point or coordinate. You pick one of the coordinate that you want. Pass through point 0, 6 and a general point or a general coordinate, a general point x, y, for us to be able to find the gradient, for us to be able to find the equation of line PQ. Therefore, now, equation of this line, we will say, I would want the equation to appear in the form y is equal to mx plus c, whereby m is the gradient. For this particular case, m represents what? The gradient. Once we know that m represents the gradient, then we are saying that c is the y-intercept. Y-intercept means when you plot this particular line PQ on the x and y axis, it will pass through the y axis at point C. X and y and x are variables. So what do? We go ahead and write the gradient. Negative 2 is equal to the general point y, subtract from it the y coordinate, y1, x1. The y coordinate is 6. Everything out of the x2, which is x, subtract from it 0. So with this one, then I'm saying I have negative 2 is equal to y, take away 6, everything out of x. This one here out of 1, then I cross multiply. So this, by this I have 1 times negative 6, I have minus 6 is equal to negative 2 times x, negative 2x. Negative 2x. Now, can I be able then to write this in the form y is equal to mx plus c? Therefore, y is equal to negative 2x plus 6. When this 6 crosses equal sign, and this becomes my equation. So that is what you're supposed to do. I want you to follow through that and give me your opinion about finding the equation of a straight line. So this is the first type of a question that you can meet in an exam. You have been given two pairs of coordinates and you are being asked to find the equation of the line. So that is what you're supposed to do. The second scenario can be whereby you have been given a gradient. Yeah, you have been given a gradient and one pair of the coordinate. So for this particular kind of a situation or scenario, you assume that always the general point or the general coordinate is x, y. Now with x, y, then you can go ahead and write your equation to appear in the form y is equal to mx plus c. Now, allow me to take you through the concept of whereby what is the relationship between two parallel lines in terms of their gradient. The relationship between parallel lines, that you are also able to take note of that and see. So for instance, I'll talk about parallel lines. Parallel lines. Parallel lines, we are simply saying these are two lines that can never meet. For example, I'm calling this is line 1, this is line 2. So if it is line 1 and it is line 2, then this is the gradient of this one is m1, the gradient of this one is m2. Then I'll simply say for, this one simply means for parallel lines, then the relationship between their gradient is two lines that are parallel, then the relationship of m1 must be equal to m2. The gradient of the first line is always equal to the gradient of the second line. I will give you an example of a question here and try to solve. Example. Line MN has an equation of y is equal to 2 out of 3x plus 6. Line MN is parallel to line PQ with I want you to go through the question and see. With coordinate at P 2, 3. Find the equation of line PQ. Can you go through the question together? The question says that line MN has an equation of y is equal to 2 out of 3x plus c. Line MN is parallel to line PQ with the coordinate at P 2, 3. Find the equation of line PQ. What do we have here that we know? The first thing that we know is that the two lines are parallel to each other. So if I was to sketch, this is my line MN. But then this line MN, I am being told that it's M, the gradient of this line is 2 out of 3. How do I know that? From the equation, y is equal to 2 out of 3x plus 6. So 2 out of 3 is the gradient of line MN. I'll try to sketch line PQ. So this is how, for instance, my line PQ will look like. So for this line PQ, because they are parallel, by the virtue that they are parallel, if this one M1 of this line 1 is 2 out of 3, automatically this one also becomes 2 out of 3. So we already have the gradient of line PQ by the virtue that it is parallel to the line MN. Therefore, they have an equal parallel. Now, what do? We go ahead and try to find what? The equation of line PQ. Now we again say let line PQ pass through coordinate 2, 3 and a general point or a general coordinate, general point x, y. Then we go ahead and equate these two to the gradient because you already have the gradient. The gradient is 2 out of 3 is equal to, what do we know? That if I am finding the gradient, then I will subtract the y coordinate from the y coordinates. Therefore, it is y take away 3 out of the x coordinate from x coordinate. Out of x, take away 2. Then I cross multiply. When I cross multiply, I'll have 3 times y is 3y. 3 times 3 is minus 9. Then is equal to 2 times x is equal to 2x. We go on. Then 2 times 2 minus 4. I want to write this my equation in the form y is equal to mx plus c to see whether my gradient here will be equal to 2 out of 3. Therefore, I'll have 3y is equal to 2x negative 4 plus 9. When this 9 crosses equal sign, it becomes positive. So what do I have? 2x negative 4 plus 9 plus 5 is equal to 3y. I want to remain with y, therefore out of 3, out of 3, out of 3. I divide everything by 3. So the equation of line PQ is y is equal to 3 and 3, 1, 1. So y is equal to 2 out of 3x plus 5 out of 3. And you can see the gradient here is the same as the gradient here. Therefore, this becomes your solution. That is our answer. So that is good. I hope you've seen the relationship of two lines that are parallel. How are they related in terms of their gradient? The next bit that I want to talk about is what we call perpendicular lines and how they are related. I hope you can follow through. Like that. So I talk about perpendicular lines and what is the relationship between the gradients of perpendicular lines. Also, a very, very important topic to take note of in mathematics. Therefore, I'll say perpendicular lines. Here, the relationship is if this is my line L1, it has to be perpendicular to line L2. So if they are related, then this is the gradient of this one is M1, the gradient of this one is M2. Then I'm saying for perpendicular lines, then I'm saying this is M1, this is M2, then this must hold. That the gradient of line 1 multiplied by the gradient of line 2, the product must always be negative 1. So this is the relationship between two straight lines that are perpendicular to each other in terms of their gradient. I will give an example to help us expound and teach you more about this. My example will go line PQ has an equation of okay, or for instance, I can talk about even the gradient is still okay. Has a gradient of 3. Line PQ is perpendicular. Line PQ is perpendicular to line PQ is perpendicular. Line PQ is perpendicular to can clean this space to work out here. Line PQ is perpendicular to line PQ is perpendicular to line MN, which which has coordinate at M 3, 4. Find the equation of line MN. So you see, reading the question, we are told that the two lines are perpendicular to each other. Line PQ has a gradient of 3. Line PQ is perpendicular to line MN, which has a coordinate at M as 3, 4. Find the equation of line MN. What do we do? First of all, before we find the equation of line MN, we must have the gradient. But then since, therefore, I'll say, let line PQ have M1 as its gradient, which is equal to 3. But then because they are perpendicular, then it means, then now I'll say line MN has M2, which we don't know. But by the fact that they are perpendicular, then we are saying if I take M1, I multiply it by M2, I must get -1. There is no negotiation about that, by the virtue that they are perpendicular. What is M1? M1 is 3. Multiplied by M2, I must get -1. So I divide everything by 3. M2 is equal to -1 out of 3. So this is the gradient of line MN. And remember, it is this MN that we are looking for its what? For its equation. The equation of line MN. Now what do we do? I'll say let line MN pass through. What is the coordinate that you have been given? We have 3, 4 and a general coordinate or a general point. And a general point x, y. Once we have these two, then we go ahead and find the equation of line P, the equation of line MN. So with this in mind, then I'll come here. I believe you are able to follow through because I need this space to work out something to find the equation of line MN. Therefore, I'll clean this. Then I'll come and say that now, for that, I'll go ahead and say, what is the gradient? -1 out of 3 is equal to y. Subtract. What is the y coordinate? This is the y coordinate 4. Subtract 4 out of x. Subtract the x coordinate. What is the x coordinate? X coordinate is 3. So what is the I cross multiply? 3 times y is 3y. 3 times 4 minus 12 is equal to -1 times x minus x. -1 times -3, it becomes +3. Collecting like terms, 3y, I want to write it in the form y is equal to mx plus c. Therefore, I'll go ahead and say -x plus 3 plus 12. What do I have? What will we have now? -x plus 15 is equal to 3y. I want to remove this 3 here. Out of 3, out of 3, out of 3. We go ahead, because I'll need some more space here. You can remove this line and now say I still don't want to remove the equation, this and this. So y is equal to -1 out of 3x plus 5. So this becomes the equation of line MN. So you can follow through the equation and you can realize that at least I've tried as much as I can to enlighten you on the various aspects of gradients of straight line, talking about the aspect of finding the gradient of a straight line from the start. We've talked about how to find the equation of a straight line. Then I've come further, I've told you the relationship between two parallel straight lines. I've also gone further to elaborate about the relationship between two perpendicular straight lines. I hope you follow through and this helps you to revise, because this is a very, very important topic in various syllabus across the world, whether it is GCSE, whether it is GCE, whether it is the Kenya system, whether it is the American system, whether it is the Canadian system, we will always learn about finding the gradient of a straight line, finding the equation of a straight line, the relationship between two perpendicular lines, the relationship between two parallel lines. So you therefore really need to take note of this and follow through. Thank you.